Good afternoon, sixth period. Sorry I'm not here. I actually love teaching this lesson and doing some math tricks with you guys. I think I told you guys on Friday I would do a trick where I can know your birthday. I'll try to do that on Wednesday, see if you guys can do it. But I'm going to ask you to do a couple mental maths with this, and we're going to talk about inverse, which we kind of talked about a little bit on Friday, or hint to. So if you guys can get out your yellow note packet and turn to 9.6. Again, anytime you want to turn any homework in, please put it in the basket on my table in the front. And you guys are doing a pretty good job of keeping it. It hasn't been too hard so far, and hopefully this won't be either. And so we'll talk about a lot of this on Wednesday. And we're almost done with this chapter already. We'll be testing next week, so you guys know. Okay, so 9.6. We're going to talk about inverses. Inverse function. So if you think about the word inverse, inverse means opposite. So we've always learned, hey, when I solve a equation, I have to do the same thing to both sides, and I always do the opposite operation. So if I'm doing something like 2x plus 6 equals 12, we know if we add, this is plus 6, we minus 6. That's the inverse operation. 2x means to 2 times 12, so we divide by 2 to find our inverse operation. Okay? Inverse function is doing the inverse operation for you. Okay, so before we get started, just a little number trick. It's a very easy one. I want you to choose any number at all. Okay, so this is mental math. You shouldn't need a calculator. When I do the birthday one with you guys, you definitely will need a calculator. This one, you shouldn't. So choose any number. Don't choose a big number. Okay, don't choose, 132, because you might have a hard time with that. Just choose a single digit number. Okay, next thing, and I would say this verbally if I was here. Add 5 to your number. Then double that. Now subtract 4. Divide by 2. And subtract the number you started with. So, you should all have 3 right now. No matter what number you started with, you should have 3. Okay, so what I did is I chose 10. Not a single digit number, but pretty easy number. Added 5, that was 15. I doubled, I got 30. I subtracted 4, I got 26. I divided by 2, I got 13. And I subtracted my original number, and I got 3. Everyone should get 3. Okay, again, that one you shouldn't need a calculator to do. The one we're going to do with your birthday tomorrow, you'll need a calculator. Well, why does this work? You may see some inverse things coming on. Doubling, dividing, that's inverse. So let's talk about why this works. So you picked different numbers. You picked an x. You added 5 to your x. You doubled it. So you took your number and multiplied by 2, so you could write it that way, or 2x plus 10. Then you subtracted 4, so now you have 2x plus 6. You divided by 2, you have x plus 3, and then you subtracted your x from it, and you got 3. Okay, so pretty cool how it works. We're doing a lot of inverses, even though you can't see. We doubled the results. You can see we're dividing, but we had to subtract 4 first before you divided. And so you may or may not be able to see this. Okay, but it did undo everything we did. And that's what an inverse operation does. It undoes things we've already did to the problem. Okay, so this is the one we're going to do on Wednesday where I can guess your birthday. But you'll need a calculator, and there's a video that goes. So we'll do it later. Okay, inverse function. So at the top of your notes on the far upper right, it has this. Let f and g be two functions such as f of g of x, which remember means fog, equals x for every x in the domain. Okay, we had a homework question like that, which I'll talk about in a second. And unfortunately I have to check both, g of f of x, or GOF, also equals x. So the operations, when you do the composite, it just undoes everything the other one did. So under these conditions, the function g is the inverse function of f, and the function of g is wrote as this. So once you find the inverse, you write a little -1. So if you've seen the inverse -1s before, when we did the inverse of sine, cosine, and tangent when you're finding an angle. Okay? So a little -1 always says inverse. And I'm pretty sure you guys did this last year. Because like I said on Friday, I just was talking to a couple of students that were in Math 3, and they were talking about that they just finished inverses. I'm pretty sure you guys did it last year. Okay, so instead of saying Fogg and Goff, we can say f of the inverse equals f, and the inverse of f of x equals f. So we don't, every time we know it's an inverse, we should be able to plug it into the original equation and get x, or we should put the original equation into the inverse and undo it. So let's see what I mean by all that. So you're not going to really pull numbers through, but this problem should look familiar, okay? And I can tell you, and you can do this on the test on multiple choice, if I pull a number through, any number I want, if I start on one equation and put that number in and get the answer and put it in the other equation, like we did with the graphs and we went through the graphs, I should get back the number I started with. So I'm going to start with 3. So I'm going to find f of g of 3. So that means I'm going to plug 3 in the g equation. So 1/3 of 3 minus 3. That's 1 minus 3, which is negative 2. And now I'm going to plug negative 2 into the g equation, or into the f equation. And I got negative 6 plus 9, which is 3. I got back my original problem. I know those means it's inverse. Let's talk here. So let's do it the other way. So let's plug 3 in. Let's find f of 3 first. So instead of putting 3 in g first, let's put let's put 3 in f first. So 3 times 3 plus 9, that's 18. Now let's plug 18 into the g equation and see if we get back 3. Well, 1/3 of 18 is 9. 1/3 of 18 is 6. 6 minus 3 is 3. That means they're inverses. You don't have to do that for a bunch of numbers. If it works for one, then it'll always work. Okay? So we'll talk about that a little bit more. So we're going to try it with 1, and then we're going to try it about the function. So we're going to try f of g of 1 and g of f of 1. So we're going to do in that same two equations. So if I do f of g of 1, I'm going to do g of 1. So I'm going to plug 1 into the g equation. Not so fun because it's a fraction. That gives you 1/3 minus 3, which is 9/3, which gives you negative 8/3. And now I'm going to plug that into the f equation. So 3 times negative 8/3 plus 9 cancels out. We get negative 8 plus 9. We get back 1. So we started with 1. We got back 1. And again, do the same thing. Start with the f equation. Plug in 1. So 3 times 1 plus 9, 12. And now plug 12 into your g equation. You get 4 minus 3, which is 1. They're inverses. And then you can do the same thing with the equations. You can do a composite. So take the f equation, and you're going to plug g of x in. So the f equation was 3x plus 9. So you're going to go 3 times 1/3 x minus 3 plus 9. If I distribute that, that's x minus 9 plus 9, which is x. I forgot what number this is on the homework, but it's one of the questions on the last homework. I think it was number 5. Do the same thing. Start with the f equation, plug it into the g equation. So the g equation has 1/3, and then we're going to put 3x plus 9 for the x minus 3. If you distribute, 1/3 of 3x is x, 1/3 of 9 is 3, 3 minus 3 is x. Works out. That means they're inverses. So that question on your homework, I think it's number 5, on the top of the back, they both came out to be x's, so they're inverses. Now let's talk about this a little bit. This is our two equations. Do they look like inverses? Maybe a little bit. One of them you're multiplying by 3 and adding 9. The other one you're dividing by 3 and subtracting 3. We'll talk about why they're inverses a little bit more in a second. But if I ask you to check if they're inverses, this is why. And you can check by plugging a number in or doing Fogg and Goff. Okay, how do you, this I think you did last year, how do you derive an inverse function? Oh, this was number 5. again, this is what you should have got from 9.5, number 5. That's what we just did on the last question. So what we did is what you guys should have got for the answer. I am going to take off one question in this homework before I stop notes. Okay, how do you derive an inverse function? Okay, there are steps to it. First step, if you can't just read the question and figure out, I actually could read this and say, I know what the inverse of multiplying by 2 and adding 4 is. I know it has a minus 4 and it has a divide by 2. And it has to be in this opposite order. So I know it'd be x minus 4 divided by 2. Okay, but if you don't know it, what you do is first put, instead of f of x, put y equals. So it's like y equals mx plus b. And then you flip your x and y. So you replace x with y and y with x. So you take this and make it an x, take that and make it a y. And now you solve for your new y. So we would subtract 4 and divide by 2, and we would get this equation, but we would write it like that. And if you're not sure, you can plug a number in and see. So if I plug in 1, I get 6. If I plug in 6, I get 2 divided by 2, which is 1. So they must be inverses. Okay, but we're going to check. So if I ever ask you to check, which I don't think I will ask you on the test, but if I ever ask you to check, what you do is you check algebraically, and then we'll talk about checking by plugging a number in other than what I just plugged in. So if you check algebraically, you're basically doing fog and Goff. But we don't call this g of x anymore. We call it the inverse because we know it should be inverse, and we're going to just plug it in. So we're going to start with the f of x equation, and we're going to plug that into our inverse. So our inverse is now going to be taking, instead of x, it's 2x plus 4 minus 4 divided by 2. Now, how do you know it's inverse? If it comes up with x. This cancel out, you get 2x over 2, which is x. And unfortunately, you have to do both to double check it's an inverse. Every once in a while, one will work and the other one won't. So we're going to do the other way. We're going to start with the f of x equation, which is 2 times x plus 4, and we're going to plug that equation in there. So notice one of them, we just took, first one we took that equation left alone, plugged in 2x plus 4 in for x. Here we're leaving that equation alone and plugging this one in here. The 2's cancel out. You get x minus 4 plus 4, which is x. So we just checked that they're inverses, even though we were pretty sure it's just a way to check. And like I said, on a multiple choice question, you can check by plugging a number in. So we're going to check by plugging in the number 3. Okay? So we are going to plug in 3. So if I plug in 3 in here, 2 times 3 plus 4, that's 10. If I plug 10 in there, 10 minus 4 is 6. 6 divided by 2 is 3. It worked. Started with 3, got 10, but got back to 3. So everything we did, tell you pick a number, but I can get you back to where I want you to be, and that's what I'm doing. Again, should look opposite. Plus 4 minus 4 times 2 divided by 2. But it's inverse. It does the inverse operations in the opposite order. So instead of multiplying by 2 first, it's going to subtract 4. Instead of adding 4 last, it's going to divide by 2. So it does in the opposite order. If you want, you can try another number. I'm not going to right now. Okay? So we're going to try a couple where we're just finding the inverses. Here's a function, and we're going to try the inverse, and then we are going to verify that it's the inverse of each other. Okay? By looking at this, not plugging a number in. So, again, first step is to make it y equals. That's number 1. Number 2 is to flip your x and y, and then solve for your new y. So if I was going to solve this for my new y, I'm going to divide by 4. I get y equals x over 4. And then when you're sure, you write it as an inverse. You have to put the little -1 because you're verifying that you know that's inverse. Okay, just to check, I'm going to do I'm going to do the composites of them. So I'm going to start with the inverse function and plug it in there. So 4 times x over 4. Yeah, that's x. And then I can do the other way. Take the equation and plug it into the inverse. I verified the inverse. Okay, so we're going to do one more inverse. I'm not doing a lot of them because I really think that you guys did this last year. And then we're going to get to odd and even functions where it looks a little bit different. Okay, this is just the solution to that. If I was here, I'd have you try this into groups. We'll just talk about it. But we're going to find the inverse of this. When I look at this, I'm thinking inverse of cube root, cubing. Inverse of plus 10, minus 10. And realize that this, I could write like this if I wanted to. It doesn't matter. But I should know it's going to have a cubed, and it's going to have a minus 10. Okay, so again, first step, make it y equals. Second step, switch your x and y. So now your x is by itself, and now get your y by itself. Well, to get y by itself, I got to get rid of the cube root. So I'm going to cube each side. And that's why we solve equations. That should make sense. Like we're solving an equation, we do the opposite operation. So that's why we're taking and we're moving things around and solving an equation. Cube root and cubes cancel out. So we get x cubed equals 10 plus y. And then we minus 10. So y equals x cubed minus 10. Once we know it's the inverse, we write it with a negative 1. And some of them are hard to check with a number. Like cube roots are pretty hard to check with a number. But you could do a composite and double check. I'm not going to, but you could do the composite and double check that they're inverses. Okay, hint on the homework. There are a couple functions that are inverses of each other, of themselves. So the inverse function and the original function are the exact same equation. Just a hint to you guys. Okay, turn the page. Okay, on the back, all we're going to talk about is odd and even functions. Well, most of it's notes, and there's a couple examples at the bottom. Okay, so let me kind of give you pictures, visual of odd and even. So basically, an odd and even function, a graph has a symmetry with respect to the y-axis. And the first thing I think of is a parabola. So whenever you have x equals, you have x comma y, if you plug in negative x, you also have that same function. I'll show you a picture. The graph has symmetry with respect to the origin. If the x and y is on the graph, so is the point negative x, negative y. That's a different one. That's respect to the origin. This one's respect to the y-axis. So two different ones. So if I plug in that, it becomes the opposite sign. A function that's graph is symmetric compared to the origin is called an odd function. And I think of the word opposite when I think of odd. So I started with x comma y, and I got the exact opposite. So maybe I started with 1, 2, and I got negative 1, negative 2. Okay, so when the x turned the opposite, the y turned the opposite. That's an odd function. Just think of opposite and odd. If the graph is symmetric to the x-axis, then when you plug in x and plug in x, you get y and negative y. This is called an even function. Okay, so an even function, if you plug in x and you plug in, oh, that's kind of a typo. We'll talk about that when we get to the graph. We'll kind of go off of that. We'll talk a little bit more on the graph. Okay, so let's give you some pictures of odd or even. Okay, this is the one that is under an even function. This is even because when you look at x and I plug in negative x, I get the exact same answer. If something is the same and symmetric to the y-axis, it's called even. So I plug in, so like for example, maybe this is 4, 4, and this point is negative 4, 4. The y didn't change, even though I changed the x. This is called an odd function because when I do it, it becomes the opposite sign. So same is even, opposite is odd. So parabolas are very symmetric towards the y-axis, and they're very even. where something like this, which is like a cubic, is an odd. If it's symmetric to the x-axis, it's not a function. Doesn't pass the vertical line test. So on these, we're going to be putting neither a lot of times. Okay, same. Y and y are both the same. Y becomes the opposite. It's odd. Okay, are these graphs odd or even? So what I would tell you to do is find a point, and I mean, we're just going to say that point is maybe 1, 1. And then this, or actually, sorry, let's say this point is 2, 1. So that's 1, 2. And this point is 0, 1. That is not symmetrical to anything. The line of symmetry is over here. I don't see if I plug in 2, I get 1 over here. If I plugged in -2, I get something way over here. This is neither. Where this one is definitely even, because I figure out this point might be 1, 1, and this point right here is -1, 1. So what happens is you plug in 1, you get 1, you plug in -1, you still get the same number. It doesn't change the y value. It's the same. This is another even function. It's also symmetrical to the y-axis, where this is symmetry is over here. And again, this point might be 1, 1, and this point might be -1, 1. Where this one is odd, because let's say this point is 1, 1 also. This point looks like it's -1, -1. They're exactly opposite of each other, so that's odd. It's also symmetric to the x-axis, not the y-axis. Okay, so how do you find if it's odd or even without graphing it? So what you're going to do is plug in -x every time. So if a function is even, when you plug in -x, you get the exact same function. Doesn't change. The f function, f of x, if you plug in -x, it's still f of x. If it's odd, if you plug in -x, it becomes the opposite. And when I mean the opposite, everything is. Like the whole function is the opposite where you're distributing negative. So again, even, everything stays the same. It's symmetrical to the y-axis. Odd is symmetrical to the origin. Again, symmetrical to origin would be this. Okay, so let's try the last A through F. Again, you're going to be plugging in -x. Okay, so all you do is you find g of -x, whatever the letter is. So everywhere there was an x, you're going to put, whoops, I forgot the cube. You're going to plug in -x. Okay? -x cubed is -x cubed, because a negative number times itself 3 times is negative. And then this would be a plus. Now look at this function compared to this function. Is it the same? No. Is it the opposite? Could I take this function, this original function, and distribute a negative and get that? Yes, it's the opposite. And so if it's the opposite, then this is called an odd function. Because that was a positive x cubed, this becomes a -x cubed. That's a -x, this becomes a positive x. So it's like when we take the absolute value and it becomes the opposite. Absolute value graphs are odd. Let's do the same thing here. Every time you want to do odd and even, just take your x value and plug in -x instead. -x squared, oh, a negative times a negative is a positive. We don't have to do anything here. Look at, is that the same? Yeah, it's the same function. So that's called even. So parabolas, a lot of times, are even, unless they're shifted right or left. This one's not. I mean, if we graph this, it'd be like this. Okay, let's try this one. We're going to plug in a -x. So -x instead of x. Oops, this is the 4th power, sorry. So wherever there was an x, we're going to put a -x. -x to the 4th power becomes positive. -x squared becomes positive. 7 stays. It's exactly the same as we started with. So again, whoops, it's even. Okay. Let's these are just the answers and pictures of the graphs. So that first one was odd. Looks like that graph, where this point and this point are opposites. This is part B. This is what the graph looks like. I just drew it for you. They become the same y. The y value doesn't change. And this last one is a cubic. Oh, whoops. I don't know why I have that again. Oh, that's C. Sorry. This one was odd too, because you have the opposites. Okay, let's try D, E, and F. Now, not everything is odd or even. We should have some neithers. So on D, you're going to plug in negative x wherever there was an x. So instead of x cubed, you're going to do negative x cubed. A negative cubed is a negative minus 1. Now look, is that the opposite of that? Well, that's a positive x cubed. That's a negative x cubed. That changed the opposite, but this did not. Everything has to be the opposite. I have to be able to say, oh, can I do this and get that? No. So this is neither. It didn't change the opposite. Only the x changed the opposite, but the negative one didn't. Okay, let's try this one. We're only plugging in for the x. So right away you should see the 5 is not going to change. But a negative times a negative is a positive. Again, that changed the opposite, but that stayed the same. So everything either has to turn the opposite or everything has to stay the same. That would not be symmetrical at all. Okay, let's try the last one. I'm sorry it doesn't have an f of x. It should. So let's just plug in negative x and write like this. So negative x to the 9th minus negative x to the 5th plus negative x. You have to put it in for every x. If you raise a negative power to an odd power, it becomes negative. Okay, be careful. This is going to be negative x to the 5th, but you're multiplying by a negative, positive x to the 5th, and then negative x. So let's check. That's the opposite. That's the opposite. That's the opposite. This is an odd function because everything is the opposite sign. Here's a couple tricky on your homework. Okay? Okay. So if you haven't gotten worksheet 9.6 yet, have the sub pick that or get that from the sub right now. And I'm going to take off one question from you to make it a little bit easier and just talk about it. So the first 8 or 7, I'm sorry, are odd or even or neither. Okay. Let's talk about number 7 really quick. Remember, this means 4 cube root. Whoops. Let's try this. 4 cube root of s squared. Or it means 4 the cube root of s squared. Sorry, s's look like 5s. So you got to think about this one a little bit. That's what 2/3 powers means. And these are s's. And it doesn't matter if it's x's or s's, you just plug in negative. So just plug in negative x. And if you'd rather change that to an x, just change that to an x. Okay? You're going to show that these are inverses by doing f of that and this. You're doing both, and they both should come up with x's to be inverses. You can take out number 10. Number 10 always messes people up, so we're just going to take it out. These should look like inverses. Somewhat. I mean, definitely 9 should look like an inverse. Okay? Okay, let's turn to the back. These you're making up inverses. Okay, so you're finding the inverse. Make sure when you find it, your answer should be f negative 1x equals whatever the equation is. That's how you write an inverse. Again, remember that this means the 5th root of x cubed. That's what it means. Or the 5th root of x quantity cubed, whatever we want to write it as. So just kind of think about that. There are on here problems of the inverse of itself, which means when you find the inverse, it's the exact same equation. Okay, tomorrow I'll do the birthday trick with you guys, and we'll go over this assignment. I'll see you guys tomorrow.